All right, so welcome officially to the first class of Mat201 Statistics. So I don't know if anybody saw on my whiteboard before we got going, I had a quote up there, and it's a quote from Mark Twain. For those of you who don't know, Mark Twain was an American author in the 1800s. Actually has ties to our area here in the Tahoe area. He lived in Virginia City and in Carson City for a while. In fact, that's where he started getting his fame as a writer, when he wrote for the Territorial Enterprise up in Virginia City in Nevada. Fun fact. But anyway, he's actually very famous for the saying that says there are three kinds of lies: lies, damn lies, and statistics. I think that's a funny quote. He actually wasn't the first one that came up with it, but he's most well known for putting it in a book. But I love that quote because it's actually very accurate. Like, statistics is one of those things where I know that a lot of us have this impression that math is math. Numbers are numbers. What they say is what they say. And I would say that that's true for math. Like, when you do 5 times 6, there's no question what that is, right? 5 times 6 is 30, period. End of story. There is no, yeah, but maybe it's not, or no. 5 times 6 is 30. So you've been trained to think that when you have numbers, those answers are absolute. Those are the numbers. That's the answer. Now, statistics is not that way. Okay. Now, what we do in statistics, and this is a lot of what we're going to talk about today, is how we do statistical design and what all the different terms are. But when we do stats, we do collect data. We do collect numbers, right? Like, maybe I ask every one of you, how many pets do you have? Right? And you all give me an answer. I've got 1, I've got 0, I've got 3. Okay, I am getting a bunch of numbers. The data, the actual numbers we get, yeah, those are numbers. Those are sacred. Those are etched in stone. But the next step in statistics is the interpretation. What do those numbers mean? What do those numbers tell us? And that's where we get into that there are lies, damned lies, and statistics. Statistics is one of those things that just because we have numbers, that's not sufficient. It's how we interpret them. And we need to make sure that our interpretation is good. All right. So I'll even tell people that stats isn't actually math. It's not. What you're going to be doing in this class, this is not a math class. I know it's listed as a math class, and most of you think it's a math class. You're going to be doing calculations, so it's a math class. Now, the math is a tool that we use in statistics. Statistics more is trying to understand about a group, a population, trying to answer questions and trying to interpret what the numbers tell us. All right, so it's a different kind of creature, and you'll see that as we go. All right, so like I said, statistics really is the collection of data, right? I ask you how many pets you have. And then there's the interpretation of the data. There are the two sides. The other thing that always goes with statistics, in fact, if you take this class at some schools, it'll actually be labeled as probability and statistics. Those kind of go hand in hand. So just so you know, probability, when we talk about probability, that's like the likelihood of an event happening. And so when it comes time for that interpretation of the data, we are going to have to really pay attention to probabilities. How likely is something to happen? Is the data we got likely, unlikely? Is this a weird thing? Should we be suspect of it? So as we go through this quarter, that's another thing I'm going to be talking about a lot is probabilities. Again, if you're like, man, I don't even know what you're talking about, that's okay, we'll get there. But these are linked, probability and statistics. Okay, so there are definitely some terms that we need to know when it comes to statistics. And so I want to spend a large portion of today giving you the language of statistics. And I'm going to apologize in advance that for a lot of you, this is going to be really boring. I mean, as a student, I hated these days. Okay, great. Descriptive statistics. That means this. Inferential statistics. Yeah, that means this. Oh, great. Here's another term. But here's the deal. We have to have this language. We have to know what we're talking about so that later when I say, oh, okay, well, we're going to do a qualitative study, you immediately go, ooh, qualitative. I know what that means. All right. So bear with me as we go through this. Like I said, it's not super exciting, but these are important terms that we need to know. All right, so I'm going to share my computer whiteboard here so I can actually write some things here for you and let you know what's going on. All right, so first of all, in terms of statistics, we really talk about statistics as there's two different kinds of statistics. There's what we call descriptive, and I just started writing descriptive. Hold on 1 second here. Okay, so we've got descriptive statistics. And then we also have, I'm going to put here versus inferential. All right, and if you're looking at that handwriting and trying to give me a pass because I'm using a computer stylus and all that, I'll just tell you my handwriting on the whiteboard is not that much better. So, but descriptive statistics versus inferential, we can really split stats into these two types. Okay, so in terms of the descriptive statistics, what we do here, this is the portion of statistics where we organize and summarize the data. Yeah. Okay, so I'm going to use our class for lots of examples, and later I am going to ask, and we're going to run some numbers on how many pets we all have. So let's just say that we're going to do that. We're going to find out how many pets everybody in this class has. The descriptive part of statistics is getting all that information, putting it into a form that is easily understandable so people can look at it and find out what we're doing and what we're actually calculating. Okay, so that's what it means when we do descriptive statistics. Think about that word, descriptive. If something is descriptive, you're describing it, you're giving it characteristics, you're talking about how it looks, what it does, all that. It's informational, right? It's informational. If I'm going to describe myself, I'm a white male, 47 years old, math physics professor, live in Nevada, right? I'm giving you all this information about me. It's describing me, right? But it's just informational. Okay, so think about all the descriptive stats. This is just the informational portion. Now, inferential statistics, this is the part that what we do is we draw a conclusion from the data. I'm also a horrible speller. I'm not sure if there are two S's on conclusion or not. I'm going to go with there's just one. Figure I got a 50-50 shot. Okay, so when we do inferential statistics, this is now where we're going to take that data and make some sort of a conclusion. So let's go to that example of I ask everybody in this class how many pets they have. So I get all those numbers. The inferential part would be, okay, so because this class on average has 2.5 pets, I'm going to assume that all students in California have on average 2.5 pets, right? So I'm making a guess about another group based on the statistics I found. All right, so, and that's what that word infer means, right? If you infer something, you're making a conclusion based on other information, right? You might look at me and go, oh, he's got a big raggedy beard, and infer from that that I'm lazy and don't want to shave my beard. Okay, is that true? Is that why I have a beard? Yes, it's why I have a beard. I detest shaving. Plus, but in the winter, man, it keeps me warm. And with COVID, it's not strange anymore. Nobody looks at me funky and be like, "Oh my God, you got a big scraggly beard." No, they just go, "It's COVID." All right. So, but you can infer, right? You can infer things. You made an inference on something about me based on something else. And that's what inferential statistics is. We're going to take this data and we're going to go, I think that tells us whatever. Okay, so when I use those words, descriptive or inferential, just realize what we're doing. Just descriptive, we're describing, we're giving, just informing. Inferring, inferential, we're making a guess. We're saying we think this because of the data. All right. Okay, so that's descriptive versus inferential. All right, now some other terms that we definitely need to know. First of all, we have the population. Now, I imagine when you hear that word population, you immediately thinking about like the number of people in a location, right? We talk about the population of the United States or the population of South Lake Tahoe or such and such, right? But in statistics, the population, this is the group, the thing, the set of whatever that we're studying. Okay, so I'm going to just call it the group that's being studied. Okay, so it's the group that we're interested in. So let's go back to the how many pets we all have. Maybe I'm curious, how many pets do community college students in California have? The population would be community college students in California. That's the group that I'm curious about. Or let's take, what's going on in the world right now. Let's take like the COVID vaccine. When we're doing our statistics and we're trying to find a vaccine that works for COVID, the population that we're studying is humans. How do humans react to these vaccines? What do we see happen, right? So there the population would be all of the people of the world. Okay, so that's a population. Now, go back to that example of trying to find out how many pets the average community college student has. And I go and I ask you guys, right? You guys are in this population. You are all community college students. However, you're not all of the community college students. I mean, you're not even all of the students at Lake Tahoe Community College. So what you guys would be is a sample. So to go with our population, we also have a sample. And the sample, this is the, I'm going to call it a subset. So a subset just means it's a group from this bigger group. So it's a subset of the population that's actually being measured. Because it might be actually impossible for me to go and ask every single California community college student how many pets they have. Right? I mean, it might actually be impossible to do that. But it's very possible for me to ask that question and get those answers from this smaller group, you guys. So that's the difference between a population and a sample. So the population is the entirety of the group, and the sample is the chunk that we're going to actually investigate and talk to. And that's what statistics, that's how they're done. You know, when you see things like, okay, so we just had that runoff election in Georgia, right? And you might see polls where they say, 49.2% of people favor, Ossoff. Okay, they didn't go and ask every single Georgia voter, right? They didn't. But what they did is they went and they talked to a sample from that population. Okay, so that's the difference between population and sample. All right. Along those lines, we also have what we call a parameter. And a statistic. So I'm going to go ahead and write those guys as separate lines here. All right, so parameters and statistics. The statistic and the parameter, these are basically the number, the number that we're using to characterize our group. All right, so the parameter, basically this is a number. That is a property of the population. So in this example that we're talking about, the parameter would be the average number of pets owned by a student at a California community college. Okay, that's going to be a number. That's the parameter. Now, when I ask you guys how many pets you have, and we figure out the average number of pets, that's the statistic. Okay, so this is that number that is a property of the sample. So let's talk about, again, go back to the very beginning here with descriptive and inferential. All right, so I go and I ask you guys how many pets you have. We get the numbers. The numbers are the numbers. I get that data, and it gives me the statistic. All right, so I know for the sample what the statistic is. And then I'm going to use you guys to infer that the parameter is roughly the same, right? Like that is the question. If I ask you guys, are you a representative sample? Do you know, are you similar to students elsewhere? But the parameter is the average number of students for the entire population, or sorry, pets for the entire population. The statistic is just for you guys. All right. So notice that for each one of these, population and sample, there's a parameter, there's a statistic. We see that a lot, that there's the name for what's going on with the entire population versus just the sample. And as we go further, that's something we have to pay attention to. For example, there's something called the standard deviation. And it's going to matter, are we talking about the standard deviation from a sample or from a population? Those are going to do different things for us. So get used to that now. Sample versus population, we need to remember which one we're dealing with. Okay, so a couple more terms, and then we'll actually do some example. We'll talk about what these different things are in those examples. Let me just clear this really quick. All right, so then we also have what's called the variable. Now, I imagine some of you have taken quite a bit of math. What's a variable in math? Like in an algebra class, when we talk about a variable, what is that?
Like the unknown factor?
Okay, yeah, it's an unknown. It's like in algebra, that's usually the x, right? We throw in a letter for it. So I like that. It's an unknown. And if you look at its name, variable just means that it can change, right? Something's variable, it varies, it can change. And so in an algebra class, it's an unknown quantity, but something that can change. All right, well, in statistics, it's a little bit different. It's still an unknown, all right? It's definitely an unknown. But what this is the characteristic that we're measuring. So in the example we've been talking about with the pets thing, the variable is the number of pets owned by a student. That's the actual thing that we're measuring. So that's our variable. Maybe what we're looking at is, what's the average height of an NBA basketball player? Okay, so the variable would be average height of NBA basketball player. All right, so when we talk variable in statistics, it's the thing that's being measured. Eye color, blood type, income, whatever it is we're curious about, that's our variable. Okay, now with variable, the other term that matters here is data. All right, so the data, this is actually the values of the variable for the sample. So I go and I ask every single one of you, how many pets do you have? You all give me a number. I make that list. That list is the data. Okay, that is the set of values for the variable, the thing that I'm measuring. All right, so I know this is a lot of terms and you're probably like, oh my God, but we need to know this. We need to be able to tell the difference so that we're all speaking the same language. So to practice, here's what we're gonna do. I'm gonna give you a couple of scenarios and we're gonna talk about what are all these different things. What is the population? What is the sample, right? What is the parameter, the statistic, the variable, the data for each of these, okay? So here's your first one. Let's say that we're curious about the average age of first-time college students. Okay, so this is your very first time in college. I want to know how old you are. Okay, so that's what we're going to be looking at. And so I'm just curious. Anybody in here first-time college student? Like this is your very first term of taking classes in college? All right, so I'm hearing none. All right, cool. So we have none of you. Thanks. That went miserably. Oh, hold on, I'm good. Oh, Lady says she is. Is that right, Lady?
Yeah.
I pronounced that right? Awesome, cool.
Could you repeat the question, Bruce? Sorry.
Yeah, no, that's fine. So is this your very first quarter semester in college? So for Bruno, where you said this is your second quarter, no, you don't count.
Yeah, mine's a no as well.
Okay. All right. So awesome. At least I've got one. All right. So this is what I'm curious about, right? I want to know what's the average age. Oh, man. Okay. So how about we'll go with first year? Because then there are a couple of you that are definitely in your first year. So who else in a first year of college? Okay, we got a ton of you. Awesome. All right, so let's change it slightly. So we're going to change this from what's the average age of a very first quarter student to, yeah, Carson, we'll take dual enrollment. If this is your first year taking college classes, you're in that list. Okay, so we want to know about the average age of first year college students. Okay, so their very first year of college experience. All right, and so what I'm going to do, and you don't have to put this into the chat because unless you want to, but so what I'm going to do is I'm going to ask all of you in our class that are first years, right? So Carson and Bruno and Ashton and Magdalene and all the rest of you. I'm going to ask you your ages so that I can get those numbers. Okay. Again, you don't have to put them in, but if you want to, that's fine. All right, so let's think about this in terms of all those different words that we just used. All right, oh wow, look at all those numbers coming up. All right, so what is the population in this experiment or in this study?
The first year college students?
First year college students. Beautiful, right? Because we're curious about first year college students. So that's the population. So what's the sample?
The stats class?
Yeah, you guys in this class, the people that have been throwing their ages up in the chat box, right? So it's all of you in this class, not everyone in this class, right? Because some of you are not first year college students, but all of you that are, that I'm asking, you guys are the sample, right? I like that because of the participants, right? The participants in the study. All right, good. So population is the entire, all first year college students, but the sample is just you guys. All right, so I'm going to do these out of order. What's the variable? Beauty Alley just put in the chat box, age. Spot on, right? The thing that we're measuring, the characteristic of these students that we're interested in is their age. So in this case, the variable would be their age. I'm going to go ahead and actually write all this stuff down while we're going, but good. So the variable is the age. How about this? What is the parameter? What would the parameter be?
That they're first year college students, right?
That's actually not the parameter. The fact that they're first year college students helps us define the population. But that was a good guess.
Is it the age of students in first year of college?
Okay, so it would be the
Amount?
average age. Yep, it'd be the average age of all first year college students. Okay, so let me catch myself up here. First year college students in our class was our sample. So the variable was just the age of the student. And so the parameter, this would be the average age of all first year students. Okay, because again, remember the parameter is it's a number. It's the number that we're looking for. That's a property of the population. So in this case, it would be of all first year students. Okay, so what do we call the average age of you guys who are first year college students in our sample? What term is that?
The sample?
You guys are the sample, but your average age?
The data?
And I saw that Ali again got that in here in the chat box. That's the statistic. The statistic is the average age of you guys. So I'm going to put of our first years. So when I look at all of those numbers that you guys threw up into the chat box and I calculate the average, that's our statistic. Okay, so the parameter is the average age for all first year students. The statistic is the average age of our group's first year students. And I don't know who that was that just said data. I wasn't paying attention, but what is the data here? What is the data for this?
I guess all the
Experiment.
ages entered into the chat.
Yeah, that's exactly right, Carson. If you go back and you look, and if we go back here, so let's see, I've got, at least these are the people that threw them in. So Bruno, 18, Carson, 17, Magdalene, 18, Ashton, 18, Lady, 19, Branda, 18, Tassel, 18, Carolina, 18. Okay, so all of those numbers, 18, 17, 18, 18, 19, 18, 18, 18, that's our data, right? So I'll even go ahead and let's put those actual numbers. Let me count those again. 1, 2, 3, 4, 5, 6. I'm thankful that a lot of you have the same age, so it was really easy for me to remember this list. 2, 3, 4, 5, 6. Okay, so this would actually be the data. It's the list of the actual numbers, the actual values for the variable, right? I mean, think about what we were doing, right? The variable, this was the age of the student. The data is the list of the variable values for our sample. And that's how it always works out. That's how it always works out. That the variable is what we're measuring and the data is the values that we get. Now, they don't have to be numbers, right? Like I could change this question where we don't actually have numbers for our data. A great example is, what if I ask everybody their eye color? Not eye color, how about their favorite color? Real quick, if you've got one, throw your favorite color into the chat.
Teal.
All right, so we've got blue, purple, indigo, purple, red. We've got teal. I'm going to go ahead and type that in just so that I've got a number for that, for teal. Oh, you beat me to it. I'll go ahead and say my favorite's teal too, even though it's not. I think mine's just plain old blue, but yeah, close enough. All right, so look at that one. We don't actually have necessarily a population because we didn't specify. We do have a sample. It's us, right? What's the variable now? What is it that I'm measuring with everybody in here?
The student's favorite color.
Yeah, your favorite color. That's the variable. So the data would be the list that we just got. All you guys that put in your red and blue and indigo and teal and, you know, there you go. There is the list of our data. All right. So in terms of like statistic or parameter, right? Again, we can't really define parameter because we didn't talk about what our population was, but the statistic would be the favorite color of the people in this class, right? So data does not have to be a set of numbers. Your data can be anything. What we do with them matters, right? Obviously, I can't exactly find out what's the average favorite color, right? I mean, that's a silly statement. What's the average favorite color in this class? I mean, I guess we could mix all those colors together and see what we get when we're done. So like that would be a stupid kind of question to answer, as opposed to what's the average age of the first year students? Oh, I can calculate that. I mean, I've got my list. I mean, I can tell you right now the average age is 18 just by looking at that list, right? But with the color example, I could say, well, what is the most favorite color, right? Which color do more people like than others? I could make the list of all the favorite colors or whatever, but clearly the question we might want to answer is going to be different if the data isn't numerical, right? but we still use those same terms. Population, it's the big group that we're curious about. So maybe let's throw one out here for color. Maybe we're curious about what's the favorite color of people that take statistics class at Lake Tahoe Community College. Okay, so there's our population is students, statistics students at Lake Tahoe Community College. Our sample is those of you that are in my section of Mat201. Right? The variable, we're looking at what is the favorite color. So the parameter would be favorite color of all LTCC stat students. The statistic would be the favorite color of our group. And the data would be the list of colors that we just threw into the chat box. Okay, so we use those same terms no matter what the study is. But just be aware so that when you're reading or we talk about something and or you're asked to mention what the variable is or whatever, that's what we're looking for. Okay, so a couple more terms that kind of go along with what we're talking about here. I want to talk about the difference between these ones that give us actual numbers versus those that give us things like favorite color or whatever. So we have two different names for that type of statistics or those types of statistics, and they are qualitative and quantitative. And I will apologize in advance for the people that gave us these two words that are so similar, but are so different. Okay, you look at those words, qualitative, quantitative, I mean, virtually the same, but they're very, very different when it comes to statistics. All right, so qualitative versus quantitative. Quantitative, these are ones that have numbers. So that first example, when we're talking about the average age of first year students, that's a quantitative statistic because we have actual numbers there. Qualitative, these are non-numerical. And I just got really fancy with you. That just means no numbers. Okay, so a qualitative statistic is one where we don't actually have number values. So when I asked your favorite color, that's a qualitative. Okay, so quantitative versus qualitative. Yeah, also known as categorical. And a great way to remember the difference is think about like the very beginning of quantitative, quantity. When we talk about the quantity of something, it's how much we have. And so if you were to answer a question of how much do we have? What quantity do you have? That answer would be a number. So quantities are numbers. So quantitative is numerical. All right. So quantitative is numbers, numerical. Qualitative is non-numerical. It's not numbers, it's categories. All right. So some other examples of qualitative, and let's just go with things that pertain to students. All right, so I ask you your favorite color. I could ask you where you were born, right? So like if I said, okay, everybody, in what city were you born? You don't put that in the chat. That's not anything that people out in Facebook world or in the YouTube world need to know. But if we say, okay, so where were you born? That's going to be qualitative, right? It's not a number. Like I'll tell you, I was born in Colorado. I wasn't born in 4. We could make it qualitative. How could you change that question, the where were you born question, to make it quantitative, make it so that there's a number? Can you think of a way?
The population of the city you were born in.
Okay, we could definitely do that. So Ali put here, you could give each category a specific number. Okay, so maybe like if we're going to go with that, where were you born? We could say, okay, let's give each state a number. Maybe, right? So we're going to number the states 1 through 50. And so then you go, oh, Colorado is state number 12. So assign 12 to me. All right, yep, that's another way we could do it. There's a really easy way to associate a number with a location. There are actually a couple of numbers. Okay, cool. Allie's definitely going where it's thinking what I'm thinking. How about zip code? Right now that one gets a little bit weird because there's more than one zip code in a certain city. So like for you guys, for us in South Lake, for example, 96150. I mean, that's the main one, but some of you may have different zip codes, right? I see some other things that people are throwing in. Altitude. Yeah, we could do the altitude of the city. Coordinate, I'm going to guess you mean they're like latitude and longitude, Carson. We could do that. How about area code? Right? 775. Sorry, I'm not really gangster at all, obviously, right? But there are lots of ways. There are lots of ways that we can even take qualitative things, so non-numerical, but make them quantitative if that's appropriate, if it's useful, right? Not always. Sometimes I like, go back to that, what's everybody's favorite color? Maybe it's totally fine that I just have a list, a qualitative list. And I go, okay, look at that. 3 of you said that purple is your favorite color. And 2 of you said blue. And 1 of you said red. And okay, cool. That's plenty fine for me. But if I wanted to, I could be like, all right, let's make red 1 and blue 2 and teal 3. And right. But anyway, so that's the difference between qualitative, so no numbers, just categories, versus quantitative, where we do have numbers. All right, now quantitative, we can even split this into 2 different groups. It's not enough just that it's numerical. It turns out that with quantitative, it matters how those numbers are or what they are. And so the first one is what we call discrete. And the second one is continuous. So with this one where we've got numerical answers, they can be either discrete or continuous. They're one or the other. And which type they are will determine what we do with them later. So we definitely need to know how to tell which is which. But it's actually really easy. Discrete, these guys are countable. These are numbers that you get just by counting, right? The fancy math term for those are what we call whole numbers, right? And a great example would be the how many pets do you have? Because when you give me an answer to how many pets do you have, it's going to be a whole number. You can count the pets. You don't have partial pets, right? I don't have fractional pets. I've got 1 dog. You've got a dog and a cat, so you have 2 pets. I don't have any pets, so that's 0, right? It's a countable number. Continuous, these are ones that aren't countable. All right, so this would be things like, what's your weight? Right? Like think about the answer to that question. How much do you weigh? it's not a countable number. I mean, we could make it, I could say, round your answer to the nearest, kilogram. But if I don't specify that, it's not necessarily countable, right? You could say, I weigh 162.48 pounds. All right, cool. That's not countable. So not countable means things like fractions, decimals, and so on. So if you can get things that have answers that are numerical, but fractions, decimals, whatever, we call that continuous. And if you think about that word continuous, continuity, continue, there's this idea of you just keep going, right? If we're going to talk about the weights of people, how much you weigh, there are all kinds of numbers that can be, right? You can start at 0. I mean, I guess having somebody that weighs 0 pounds would be a little bit weird, but but we can go from 0 all the way up to hundreds of pounds, and you can have any number in between there, right? So it's nice and continuous. Discrete just means there's a jump. There are only specific values, right? Now, some things, I'm going to warn you, some things you actually can treat as discrete or continuous. Can any of you guys think of a number that we use that, or if I were to ask a certain number about you, that we could treat as discrete or continuous if we were good about it? I mean, weight is an example, but can anyone think of another one? All right, so Ali just put in height. Yep, height's the same deal, because we could go to the nearest inch, right? I'm 6'1". I'm 5'7". Okay, cool. Yeah. Ooh, shoe size. Now, shoe size is a little bit interesting. So Carolina just put in shoe size, because shoe size, we have different ways of measuring shoes depending upon where you are. I don't know if you've ever noticed this when you go and you buy your shoes and you look at the tag that has the size on it. It has different numbers. There's the number for the US, but also the number for the UK. I think the other one is for Europe, right? But you get 3 different numbers. Now, shoe size is one that isn't really continuous, unfortunately, because there are like set shoe sizes. But if you went to foot size, you go to foot length, then that one definitely could be continuous. How about this one? It's one I already asked you guys. What about age? Right? When I asked you your age and you guys all started throwing your numbers into the chat box, you all gave me discrete numbers, right? 18, 17, 19. But for, let's go Carson, because you're the one that I remember was 17. So Carson, are you exactly 17 years old? Like, were you born 17 years ago right now?
No.
No. Right. And I didn't know that for sure, but it was a good guess that that wasn't the case, right? So think about it. Is he actually 17 years old? No. He's 17 and more. He just hasn't reached his 18th birthday yet. So we could actually treat this as continuous if we went into decimals or fractions, right? Even if we just went to months, right? If you went, okay, well, I'm 17 and 10 months. So you're 17 and 10/12. That now immediately makes it a continuous value instead of discrete. So just be aware that with discrete and continuous, sometimes there are quantities that can be both, depending upon how you ask that question. All right, but if it's such a way that the only answers that come back are whole numbers, that's discrete. If what comes back are whole numbers, but also fractions, decimals, anything else like that, that's now continuous. So in general, usually age is treated as discrete, right? We don't normally talk about how many fractional years old we are, right? It's a whole number. I'm 47. That's what I say when people ask me how old I am. I don't say I'm 47 and so many months old, or I'm 47.6837. Like, I don't do that. It's hard enough to remember that I'm 47 without bothering with all the rest of it, right? So we just give our age, it's a discrete amount. So ages tend to be discrete. Anytime we talk about number of children, number of pets, number of years in school, that kind of stuff, those tend to be discrete. Continuous are heights, weights, times, lengths, all that kind of stuff tend to be continuous. All right, so are we good with the difference between qualitative and quantitative? Give me a thumbs up or a yes. Do you guys know about the thumbs up button here in Zoom? Oh, Bruno does. He just gave it to me.
Is it in more? Oh, I see it.
Yeah, so there are reactions. There are a couple. There's like a hand clap, I think, and stuff like that. So if you ever want to give me just like if I ask, are we good? And you want to give an affirmative, you can just give me the thumbs up and I'll know. Okay, so you feel good about qualitative versus quantitative. And how about discrete versus continuous? Making sense? Yeah. Okay. Good. I'm seeing some more thumbs up and yeses. All right. Cool. So what we're gonna take a little bit of a break here. I've been talking for a long time. I just need to take a real quick breather. So I'm gonna stop sharing here for just 1 second. Hold on here. I almost did something bad. I am actually really, really flustered because of my phone. So, 1 second. Okay, so we're back in business. Let's keep talking about some of the terms, terminology that we need for stats. Let's blow through some more of this just so we've got it. But I think so far you're doing pretty well. You're understanding what we need to do and how we characterize things and the words we use. So let me give you a couple more now that have to do with different kinds of sampling. Now, what's going to be really important when we do this, and like when you guys do your projects, is how do we pick our samples? Remember, the sample, this is the group that we're actually studying, or that we're actually going to measure, that we're using to describe the population as a whole. And what we need to really make sure happens is that our sample is representative of the entire group, the entire population. And let me give you an example of how this could fail miserably. Like, let's say what we want to find out is how folks from the United States feel about, or maybe how many guns they own. Okay, so this will be a quantitative, discrete, right? Super easy. We're just going to go, we're going to say, how many guns do you own? So we're going to see on average, how many guns are owned by people in the United States. All right, so that's our population. That's what we're looking at. We need to create a sample. So suppose I were to go and ask 100 people how many guns they own. And I come up with an average and I say, oh, from these 100 people, on average, they own 12 guns. What do you think? Is that a representative, an accurate approximation of how many guns an average American has?
Probably not, right?
Probably not. I think that's probably on the high side or on average, right? And I'm not going to ask all of you guys, but I would be willing to bet that us as a group, the average is way under 12, right? But what I didn't tell you is that those 100 people I asked were all at an NRA convention. So suppose that I went to NRA, National Rifle Association. So suppose I go to an NRA convention and I ask, how many guns do you own? I'm going to get very different numbers than if I went to, to an elementary school and I asked the kids walking out of the elementary school, how many guns do you own? I would hope that the answer to that is 0, right? Maybe their parents
that's the ideal,
right? But obviously, I can ask the same question, but to a different group and get a very different answer that might not actually be a good representation of the population that we're looking at. And if the population here is all people in the United States and asking about gun ownership, maybe going to a group that tends to have higher gun ownership is not the best way to do it, right? So we have to be really careful with how we sample, how we choose to get this smaller group to represent the population. So what we want is what's called a representative sample, which is one that's fairly accurate, going to be fairly accurate, so that when we compare those numbers, when we look at the data, right? When we look at that collection of data and we get that statistic, that statistic is similar to the parameter, right? We want those things to be kind of good. So in terms of sampling, there are lots of different ways we can do this. So let me give you some of them in the terminology here. And so these are different sampling types. All right, so the first one is what we call simple random. And it's exactly what it sounds like. It's completely random. All right, so what we do when we get our sample is we just randomly choose them. There's nothing that we're using to base it off of other than just randomly picking them. So, for example, let's take our class as the population. And let's say I wanted to pick a sample from you guys. What I could do is I could number all of you, right? Like I've got a roster with all your names on it. And so I have no idea who's up at the top. So we'll just put Bruno up there. So let's say Bruno is number 1, right? Carolina's number 2, Carson's 3, whatever, right? And then maybe I have a die. Maybe we'll go through there 20 of you guys. So I've got a D20. Yeah, I played Dungeons and Dragons. So you like that as a kid. It's actually been a long time since I played D&D. But I got a D20 and I roll it. Oh, look, 3 came up. I don't remember who I said was 3, but let's say Carson. So I was like, all right, Carson, you're part of my sample. I roll the die again, and oh, look, number 1 came up. Bruno, you're in the sample. That would be simple random sampling. Just completely random, not based off of anything whatsoever. All right, so this is just the sample is chosen at random. Now, I will tell you that doing simple random sampling is actually, it's pretty much impossible. It's pretty much impossible to make it so that you are doing this completely randomly, because there's a lot of stuff involved that can lead to it not being random. So in general, we don't do simple random. I go back to that example of gun ownership. How am I going to randomly pick 1,000 people from the United States, like randomly, choose 1,000 people from the United States to ask about how many guns they own?
Internet?
But is everybody on the internet?
No.
Even if you think about like the census, right? Census just happened. Do we actually have a list of every single person? All right, and then what about, okay, so door to door? Is door to door random? Not really,
Yeah,
right?
no.
I mean, that's not random. I mean, even if I go randomly pick doors of random houses or apartments, how do I even do that? How do I choose that, you know, when I come knocking on your door, and you're like, oh my God, what's my math professor doing here? Oh, I'm just here to ask you a question. I just randomly picked your house. How do I even go about doing that? Picking your house randomly, right? So you can see how it can be very challenging to do actual random, especially if our population is large. When I first proposed well, I'm going to pick people from this class, I can easily pick a random sample from the class. Even though, like when I said I'm going to roll a d20, like you roll a die, believe it or not, it's not exactly random. A lot of dice actually do have some tendencies. So there could be more likely that a 3 comes up instead of a 17 or something like that. So simple random doesn't usually happen. But it makes sense what it is. I'm just going to randomly, just like with no regard to anything, I'm going to randomly pick. And you can imagine that this does a pretty good job of giving us a representative sample, right? But not always. Like, let's say we're on gun ownership, and I'm going to go and I'm going to ask 1,000 people. And what if I randomly pick, because it could happen, what if I randomly pick 1,000 people that are in the NRA? Or what if I randomly pick 1,000 police officers? Or I randomly pick 1,000 military members, or right? Like that could happen. I would still get a non-representative sample, right? So it's still possible to get non-representative samples, but what you could do to help fight that is make your sample bigger. Because what if instead of only asking 1,000 people, I asked 10,000 people? Now randomly picking 10,000 cops, that's way less likely. If all I'm going to do is sample 10 people, I could easily find a group of 10 police officers just randomly, right? So you can counter that by making it a bigger group. Anyway, so there's simple random. Now, we don't usually do this. We usually use some other kinds of sampling because they're either easier or they do a better job of what we're looking for. So another one is what we call systematic. So you look at that word, systematic, that suggests having some sort of a system for how we pick our sample. And this is where we pick people to be in our group. Yeah, there was a good example Carden just put in the chat, every 4th person. Yeah, it's like, okay, so maybe we're going to look at shopping habits at Rayleigh's. How much money did you just spend at Rayleigh's? And so what we do is, as people are coming out, we ask every 4th person, every 10th person, right? Or we're going to, try to get people's idea, how many handguns they are, how many guns they own. But we're going to go in the phone book and take every 10th person in the phone book, right? I know phone books don't exist anymore, but you get the idea. Right, so systematic is exactly that. There's we sample, and I'm going to be mathy, and I apologize. Sometimes I get a little mathy, but this isn't too bad. But we're going to sample every nth person, let's say. So every 4th person, 10th person, 100th person, and so on. So I don't remember who did that. Somebody threw in the chat box, people in blue shirts. Okay, so if we went and we just sampled people in blue shirts, that's actually not systematic, because they're not, well, not likely systematic, because we probably don't have blue shirt people coming out every third person, every fifth person, every 10th person. That's a different kind of sampling. We'll talk about that in a second, what that one is. Right, but this literally is just every 10th, 100th, whatever. So yeah, it has to be consistent. That's exactly right. Because if we ask every person in a blue shirt, we might get person number 1, number 4, number 5, number 30, number 900, right? Like it could be really sporadic, and it's not systematic. It's not regular. So think of systematic as regular, at a regular interval. This could be like we go out, maybe we're looking for traffic on Highway 50, right? And so we're on whatever our stretch of Highway 50, and we go, okay, we're going to go out every hour. And every hour we're going to count how many cars are at the stoplight at Highway 50 and Ski Run. So we go out at 8 a.m., 9 a.m., 10 a.m., 11 a.m. That would be systematic. It's at a regular occurrence, same every time. Okay, so that's systematic. All right, now systematic may not be what we want, right? We may not want every fifth or every 10th or every whatever. So we also have some other ones. The next two are very similar. I'm going to warn you, these are very similar. And so we need to pay real close attention to which one's which. I'm going to go ahead and put them both up in terms of their names, and we'll talk about the difference between them. There's stratified. And there's cluster. Now, that example of the blue shirts, that's actually cluster. That's a cluster sampling. But here's how this works. So let's start with stratified. What we're going to do is we're going to split the population into groups. And those groups, we call them strata. That's a set of strata is what we get when we stratify. So we split the population into groups. I'm just going to put down here, these are called strata. And what we do is we sample a random subset of each strata. Okay, so let me give you an example of how this would play out. And let's do this. We are going to be, we're interested, our population is students at Lake Tahoe Community College. Okay, so that are taking a math class. So it's any student at the college who takes a math class, that's our population. So what we could do is we could split the population into groups, maybe what math class they're taking. So all of you guys would be in one of those smaller groups, one of those strata. But the students that are taking Math 106 with me, it's my calculus class, all right, those students are another strata. The students that are taking pre-stats are another, and so on. And there are even more strata from statistics, because there's you guys, but they're also at the end of this section. But basically what we did is we took all the math students and we split them into their groups. You're taking stats section 1, stats section 2, stats section 3, math 106, math 203, math 159, right? So we just split everybody into groups. And then what we do is we go to each of those groups and we pull a random subset from them. So somebody comes into our class, rolls the dice, and says, all right, Tassel, you're going to be checked, and Allie, you're going to be checked. Okay. And then they go to my calculus class. They roll the dice. All right, Triton, you're in that group. Isabella, you're in that group, right? And they make that. Okay, so would grade-based groups qualify for stratified? Yes, absolutely. Like if we go to like the high school model with, you've got, well, we'll just go high school. So you've got, freshmen, sophomore, junior, seniors, 9th, 10th, 11th, 12th grade or whatever. Yes, we could definitely do that. Like if we wanted to find out something about high school students, how many hours do they study per week? And we might go, okay, let's split them between freshmen, sophomore, junior, seniors. And then within the group of freshmen, we randomly pick a group to include in our sample. Then we go to sophomores, juniors, and seniors. All right. So GPA, we could stratify using GPA. Like you might say, okay, let's take all students whose GPAs are between 3.5 and 4. And 3 and 3.5, 2.5 and 3. Any way that you can do it so that you are getting everyone in the population into one group and only one group is a way of stratifying. Yeah, so there are lots of different ways of doing it, but you have to make sure that everyone in the population is in a group and nobody is in more than one group. So like this wouldn't be a stratification. If we said, let's take Lake Tahoe Community College students, and we're just going to separate them by class, the strata are going to be the individual classes. Now you might go, but Bruce, isn't that what you just said was a way of stratifying? I don't know if you caught what I said. I said all Lake Tahoe Community College students, as opposed to Lake Tahoe Community College students taking math classes. Because do you see why that would be a problem? If we're going to try to stratify all students by just the classes that they're in? How about this? Are any of you guys taking more than just my stats class? Yeah, a couple of you. All right, so you guys would be the problems. It's not a problem that you're taking more than one class, obviously, but you'd be the problem for why that wouldn't be stratified, right? Because all of you that just said yes, right? Last one I just saw was Tassel, right? That would be a problem because Tassel, you're going to be in more than one of those groups, and I can't have that if I'm going to stratify. Stratify means literally I'm taking it and everybody gets into one category. Okay, so that's stratified. Now, if you think about that blue shirt one isn't stratified, but it is cluster, because here's how cluster works. Again, cluster, we're going to split the population into groups, just like before. Now, these groups, they're not called strata anymore. They're called clusters. All right, so we're going to split the population into groups called clusters. And we're going to randomly choose clusters. And measure all members of the cluster. So I warned you that these are really, really similar, and you can start to see why. Okay. But here's the difference. With stratified, right? Go back to the math students. You're all split into your math classes. And I go in and I randomly pick some from each of the math classes. For this one, cluster, I split you all into math classes, and then I randomly pick some of the math classes. So I roll my dice and, oh, look, okay, calculus, you're in that list, and oh, section 3 of statistics is in that list, and oh, math 152A. All right, so I randomly pick some of the classes, but then I go and I sample, I measure every single person in those classes. Okay, so now with cluster sampling, the randomness is in the choice of the clusters, where stratified, the randomness was the choice of people in each of the groups. So for both of these, we're splitting into groups. It's just for stratified, we're testing some of the members in each of the groups. And with cluster, we're testing or measuring all of the members of some of the groups. So this is how the blue shirt thing could be cluster, right? Like, here's how we could do. We could say we're going to split the population, people that are shopping at Rayleigh's, by color of shirt they're wearing. So we've got blue shirts, yellow shirts, green shirts, red shirts. Unfortunately, those are the ones that always get shot on away missions. But we get everybody by those different colors. I don't know. That was a dad joke, by the way. Star Trek, red shirts. So we split everybody by color shirt. And then we go and we randomly, however we do it, decide the color. So maybe in our dice rolling, we come up with blue shirts. And so that cluster, blue shirt people, we're going to ask all of them. So in that example of using all the blue shirt people at Rayleigh's could be a cluster thing. And you notice I just said could be, because it's also possible if we decided to split people up that way by what shirt they're wearing, what color shirt they're wearing, that our random choice of color isn't blue, right? Maybe our dice come up with, oh, check the people with yellow and the people with black. Okay, those are the ones we're going to do. But that's the difference between stratified and cluster. I promise the more of these that you look at, the easier it'll be to determine which is which. But just think of it as stratified is you test some from all categories. Cluster, you test all from some categories. It's just the reverse. All right, so all of these have some sort of randomness to it. And in general, you want randomness in your sampling. Otherwise, you're most likely going to get some sort of bias. You're going to get something in there that is going to affect the numbers. It's going to make it so that they're not necessarily representative of the entire population.
Skew them.
Yeah, it can definitely skew things if you don't have randomness. But sometimes you can't even do these. And there is another one I want to mention that is definitely not random. And this is what we call convenience sampling. And convenience is exactly what it sounds like. You create your sample because it's easy, right? You create your sample in a way that is easy / convenient, hence the name. Okay, so examples of convenience sampling would be, all right, I want to know something about Lake Tahoe Community College students, so I'm just going to ask you guys. Why am I asking you guys? Well, because you are students that I have access to. It's pretty easy for me to get answers from. it's very convenient. Another example would be, all right, we're at Rayleigh's. We want to find out people's shopping habits. I'm just going to ask the first 100 people that walk out the door. How much money did you spend? That's convenience. It's not random. I mean, there is a little bit of, yeah, who are the next 100 people coming out? But I'm being lazy. I'm trying to do this in a real convenient, easy way. And the problem is that may not actually get me good information. Like, let's go to that example of Rayleigh's grocery store. We're looking at how much money people spend. Can you see how convenience could still be a problem? Like, what if I just asked the first 100 people that walk out the door of the grocery store how much money they spent? Can you see how that could still be a problem in terms of skewing my sample from being a representative sample of the entire population of people that shop at Rayleigh's? Anybody think of any scenario where that could be a problem?
We might just be like broker here than like people in like, I don't know, like Dallas.
How about this? How about this? Do you think people that pop into Rayleigh's at 10 o'clock at night spend as much money as people that are shopping at 10 o'clock in the morning?
Yes and no.
That's a legit question. I think probably not, because I know that if I'm popping into the grocery store at 10 o'clock at night, it's usually because my wife wants, cookies. I ran out of root beer. Oh no, we need to get, milk for the morning, right? 10 o'clock at night grocery shopping tends to be more impulse, random stuff that you need to get, right? Who's going to go shopping at 10 o'clock in the morning? Well, that's going to be, the dad who's carting the kids to through the grocery store to get the stuff for the week, right? You're going to get the people that are planning more. My guess is that you would get a very different result if you asked 100 people walking out of Rayleigh's at 10 in the morning as opposed to 10 o'clock at night, right? So there are potentially things that could impact the results you get if you just go to convenience. Like, yeah, I don't know who's in the store, so the 100 people that walk out could be buying anything, but there are other things involved that I might not be aware of, and that's where we might want to do stratified or cluster, right? Like, here could be cluster. Let's break up the people at Rayleigh's into half-hour chunks, randomly pick some of those half-hour chunks, and then ask every single person that walks out of the grocery store between 9:30 and 10 in the morning, how much did you spend? And everybody that's there between 1 and 1:30 in the afternoon, how much did you spend? We're probably going to eliminate some of that time-dependent stuff, right? So hopefully you're already starting to see that creating a sample is not easy. Well, no, that's not true. Creating a sample is very easy. I can get 100 people to answer my question easily. What's hard is creating a representative sample, a sample that actually is a good representative of our population. And so when you end up doing this, and you guys are going to do this when you do your projects, you really need to think about how can we create this sample so that the information we're getting is useful. That's really what it's about. Is you don't want to go through all this effort, get numbers, and then not be able to use them. Or use them and then have somebody go, well, that's a bunch of BS. You just gave us crappy data. This doesn't mean anything, right? Which comes back to lies, damn lies, and statistics, right? I mean, the numbers are the numbers. I can go ask 100 people how many guns they own, and I get data. But the problem is that data relevant? Or am I lying to you? Am I pulling some shenanigans. And speaking of that, let me look here because I wrote it down. I'm not sure what page. In the book, there's a good page. It's on page 20 in your book, and it actually gives you a list of a lot of different problems that can come up when you're trying to do a statistical study. Things to be aware of, and these are things that I hope when you look at stuff out in the real world, when somebody says, "Oh, hey, 47% of the people think blah," these are things I hope you consider, because they're definitely things I consider. Things like, is there bias in the question? Did they go and ask people because those people are going to answer the way they want, right? Like if I want to show that people in the United States are very much in favor of gun control, I'm not going to go to the NRA and ask them. The wrong group, right? Instead, I could find a group like, oh, I find some people that are fighting, they're marching against gun control or against gun ownership, and I go and ask them, oh, well, they're my people, right? So you got to look at, is there bias? Like, who are they asking? Look at things like, are the questions worded in such a way that they influence you to answer one way or another? This is one of my favorites. I get this a lot, especially in election cycles, right? Like leading up to the elections. You'll get the ones where they call them, they're asking your opinions about stuff. And so they'll say something like, okay, what is your opinion of, and I'll go with my representative, Mark Amadei, representative for Northern Nevada. What's your opinion of this person? Okay, so you answer. And then they say, if we told you that Mark Amadei voted against funding for schools, how do you feel about him? Right, and they do this a lot. And this one always cracks me up, because this is definitely one of those where they're kind of influencing your response, right? Like they're going, he did this thing. Oh my gosh, he did this thing. That's going to sway my opinion one way or the other. And sometimes they want to know, because they look at like what kind of ads would be effective and all that. But those ones, whenever I get those, I start getting really, really cautious, and I start questioning them. I'm like, what are you trying to do here? Because you're influencing the response, right? You can do things like not include all the data. Oh, that's a horrible one to do. I talk about something that's unethical, right? These are numbers that I don't like. I'm just going to throw them out, right? When you mislead with stuff like that. So there are lots of ways that you can take numbers. Numbers are numbers. The results are the results. But you can twist them. You can twist them. And that's why you got to be really, really careful with statistics. And when you guys do your projects, this is something that we're going to talk about. Like, how do you make sure that you eliminate a lot of this and make sure that things are accurately representing what you want, so that you can infer proper things. All right, I think we're almost out of time. I'm going to stop. I think this is a good place to call it for the day. But before I sign off, just want to remind you about a couple of things. One, make sure you get into the Canvas shell. Start looking at the homework, start, kind of navigating, getting used to it. Make sure you reach out to me if you're having any issues whatsoever. Our next class is going to be on Tuesday, same time, same Zoom login. So you can find me here. All right, so just so you guys know, we're not quite done with chapter 1. We're slightly behind schedule, but that always seems to happen on day 1, and that's not that big of a deal. But we'll definitely catch up. All right, so with that, I'm going to go ahead and stop our recording,